This is the second question of this paper 1 of JEE Advanced 2025. In this question, it is given that in the scattering experiment, a particle of mass 2m collides with another particle mass m, which is initially at rest. So initial velocity of this one is 0. Let me write it like this. The u1 is for this 2m, it is given as u, then the u2 is 0. Okay. Assuming the collision to be perfectly elastic, so E is equals to 1. The maximum angular deviation theta of the particle. So theta max we need to calculate. How much is the maximum angular deviation? Okay, of course, here when this is happening and scattering is happening, it is not a 1D collision or head-on collision. If it would have been a head-on collision, then the particle would have moved in a straight line. Okay, so what is happening is, I will think it like this, that this is one particle, okay, and this is the another particle. When they are hitting, they are like this, that this particle is moving with the u velocity and the line of impact is at an angle. Let me take it like this. Okay, so this is the line of impact, this is the horizontal line like that, and line of impact makes an angle phi in that direction, or yeah, let us take that this angle is phi. Okay, so let us apply the condition of collision and then find out the angle of deviation for the particle 1. I'm taking this as particle 1, and this is the particle 2. Okay, so use component. Okay, let us apply the coefficient of restitution. So velocity of approach in the direction of the line of impact, in this direction line of impact, velocity of approach of this particle, it means this component. Okay, the velocity is this component, which is u cos phi. So u cos phi is equals to, let us suppose after the collision, it is this particle is moving with a velocity of v1 in this direction, and with a velocity of v2 this particle is moving. So velocity of the separation is v2 minus v1. This is one equation. Then we are applying the conservation of momentum along the direction of line of impact. This mass is 2m and this mass is m. So I can say the initial momentum is 2m u cos phi. Okay, must be equals to final momentum, that is 2m v1 plus m v2. This is the second equation. Okay, of course we can cancel out the m from here, and then we have 2u cos phi is equals to 2v1 plus v2. Okay, so this is our second equation. Okay, then let us add okay, let us subtract the equation from the equation 2. I'm subtracting the equation 1. So this side I will get this, if I subtract, so v2 and v2 will be cancelled out, and then 2v1 plus v1, 3v1, and this side I will have 2u cos phi and this u cos phi, so that is u cos phi. Okay, so from here v1 becomes u cos phi divided by 3. I just need this much only. Okay, now let us go again to this particle 1. Particle 1 right now is having some velocity in this direction. We have calculated this velocity. If it is doing perfectly elastic collision at an angle phi like that, so this velocity comes out to be u cos phi divided by 3. Okay, and this direction, this momentum of this particle will remain unchanged because there is no impact in this direction. That is why the huge component in that direction, this huge component in this direction is u sin phi, that will remain constant. Okay, so we get this side is u sin phi, that is constant. Okay, now I want angular of I want the deviation. How much is angular deviation? So this is one vector and this is the another vector. The resultant of these two vector is somewhere like, okay, let me draw another diagram, somewhere like this. Okay, which has some component in this direction. Okay, and this some component in this direction. So there is a component in y direction and there is a component in x direction. Then I can say, of course, tan theta is equals to vy divided by vx, right? Vy divided by vx. Okay, let us also take the angles again. So here this angle is phi. If this angle is phi, then this is 90 minus phi, then this angle is phi again. Okay, so then the component of this u sin phi in this direction is u sin phi cos phi, u sine phi cos phi. The component of velocity in this direction is u, okay, u sine phi and sine phi. The u cos phi divided by 3's component in this direction is u cos phi sine phi divided by 3, and this direction component is u cos phi divided by 3 times of cos phi. Okay, with these help of these components I am calculating tan theta. Tan theta is vy is y component, and y component is, okay, I am taking this component larger than this component, so resultant is going to be u sine phi cos phi, okay, u sine phi cos phi, and minus of u sine phi cos phi divided by 3, okay, and divided by, and then the horizontal component, which is u sine square phi plus u by 3 cos square phi. What I'm doing is, in this complete I'm cancelling out this u, okay, and I'm multiplying with 3, the denominator and the numerator, okay, the complete. Then the tan phi is, tan theta is, this becomes 3 sine phi, okay, so basically this is sine phi cos phi and sine phi cos phi divided by 3, so this becomes 2 by 3, and so basically it will be 2 times of sine phi cos phi because 3 is cancelled out, and then here we have 3 sine square phi and then 3 cancel out, so then cos square phi, so we have 3 sine square phi plus cos square phi. Okay, we have like this. Let us do a bit simplification here. So this is basically sine 2 phi, so this is sine 2 phi, and then this is, from here we get this one, this is 3 sine square phi plus cos square phi. Okay, so I can write it as maybe from here sine square phi plus cos square phi is 1, so 2 sine square phi plus 1. Okay, and as far, okay, we know that this is 1 minus cos 2 theta is 2 sine square theta. Okay, if we add plus 1 here, so then we plus 1 here. Okay, so basically we can also write in the terms of so sine tan theta becomes equals to this much, how much is that, sine 2 phi, so that is sine 2 phi only, and in the denominator we have this, that is 2 minus cos 2 phi. Now I need to calculate maximum angle of deviation. Maximum I need to calculate, so I will apply the process of maximum. So I will differentiate it. Secant square theta d theta divided by d phi, because phi is a variable, I can have any angle of impact, and then sine phi 2 phi differentiation is cos 2 phi, and times of this value, which is 2 minus cos 2 phi, okay, and then we have minus of, and then sine 2 phi will remain same, times of this differentiation, this is 0 and this becomes minus minus plus, because, okay, and the 2 times of sine 2 phi I will have like that, okay, and divided by the square of that, anyway that is unnecessary, so cos 2 phi square will equate it to 0. When you equate it to 0, basically the numerator becomes 0, so we get here, let me just simplify it, so we get 2 cos 2 phi, and then this and this becomes minus of, okay, and there is 2 as well, okay, somewhere we have missed here, there is 2 in the when we do the differentiation, so it is 2 times of cos square 2 phi, and then again here it is 2 times of sine square 2 phi equals to 0. Okay, now this is basically minus 2, okay, so we get cos 2 phi 4 times of that is equals to 2, so cos 2 phi is equals to 1 by 2, so 2 phi becomes 60 degree, pi by 3, so phi becomes pi by 6. Still we have not got the answer. This is phi value, and now we need to calculate tan theta value from there. So tan theta is sine 2 phi. So that is sine 2 phi means sine 60 divided by, in the denominator we have 1 minus 2 minus cos, and that is 2 phi. Cos 2 phi is cos 60. Okay, so this value is root 3 by 2 divided by 2 minus 1 by 2. Okay, so this value is root 3 by 2 divided by, and this value becomes 3, okay, 4, 3 by 2. Okay, 2 cancel out, so basically we get 1 by root 3, and if we get 1 by root 3, then theta we can say is pi by 6. Okay, so maximum angle of deviation is going to be pi by 6. So option D should be correct in that. Hopefully the calculation is correct.